4 minus lambda, 3 minus 7, 1, 2 minus lambda, 1, 2, 2 minus 3 minus lambda. And we have to write a determinant, which is going to be equal to 4 minus lambda times 2 minus lambda. And by the way, I can multiply this by minus 1 and this by minus 1. And we can write this one as lambda plus 3 times lambda minus 2 times lambda minus 2 minus 2. Then we can pick, let's pick up this one, minus 1. So we can say here minus 1 times 3 times minus 3 minus lambda, so we multiply these two, plus 14 plus 2 times 3, so we multiply these two, 3 plus 7 times 2 minus lambda, 2 minus lambda, this should be equal to 0. So we have a polynomial of third order, and this term, this will be equal to lambda squared plus lambda minus 6 minus 2 minus 8. So we multiply these two together, and then here this is equal to minus 9 minus 3 lambda plus 14. Then this becomes minus 9 plus 14. This is 5 minus 3 lambda. Okay, and then here we have 14 minus 7 lambda. 14 plus 3. This is 17 minus 7 lambda. That is good. And then let's continue on these terms. Then let's multiply first the 4. We get 4 lambda squared plus 4 lambda minus 32 minus lambda cubed minus lambda squared plus 8 lambda minus 5 plus 3 lambda plus 34 minus 14 lambda. This is equal to 0. Let's get down to the higher order. This is minus lambda cubed. Then let's do for lambda squared plus lambda squared times what? This is 4. 4 minus 1, 3. That's it. 3. We get here 3 plus lambda, and lambda here we have 4 plus 8, 12 plus 3, 12 plus 3, 15 minus 14, 1. So this is just plus lambda. Then we have the numbers lambda to the power 0, which are minus 32, minus 5, this is minus 37, minus 37 plus 34, this is minus 3. Minus 3, this is equal to 0. So let's multiply by minus 1 so that we can make this look a little better. This will become lambda cubed minus 3 lambda squared minus lambda plus 3 equal to 0. So now we have a polynomial in third order in lambda, so we call this one P3 in lambda. And then to find the lambdas, good choices or good attempts to check for will be the multiples of these 3. So the lambda could be equal to 1 minus 1, 3 minus 3. Okay, if we're talking about an integer. So let's try them one by one. Let's try if lambda 1 is a root. Okay, so let's check lambda equal to 1. Is this a root? This is the question. And let's substitute here. Lambda cubed, this is 1. So 1 minus 3 minus 2 minus 3 plus 3, it's a root. Yes, okay. Because when we insert here 1, this equality is satisfied. So let's double check this again. 1 minus 3 minus 2 minus 1 minus 3. It's a root. Okay, so we found one root. Good for us. We found one lambda. Then, if this is a yes, then we can say the following. We can say that lambda minus 1 is a factor of the polynomial of third order in lambda. So at this moment, what we can do is that actually we can check also if minus 3 is a root. I doubt it, but let's check. Minus 1 to the power 3 is minus 1. Minus 1 minus 3 minus 4 plus 1. It's minus 3. It's also a root. Okay, it looks also lambda minus 1. It's a root. So we are really lucky in this case, but let's double check because I doubt it. So minus 1 to the power 3 is minus 1, minus 3, plus 1, plus 3. Yeah, this is 0. Okay. So apparently this is also a root. We found the second eigenvalue. We wish this was a little more harder, but what can we do? Let's try lambda 3. If lambda 3 is a root, lambda 3 to the power 3 is 27. 27 minus 27 minus 3 plus 3. Okay, it's also a root, so this is super easy. I was wishing for this one to be a little. So we found everything. Okay. So we found the 3 eigenvalues. Minus 3 most probably cannot be a root because we found 3 at least. We cannot expect the fourth one. So this was okay. Now let's assume that we randomly found the lambda. Maybe the problem is not this easy. Then based on this statement here, what we could do is the following. We can divide, we can take the division of this third order polynomial like this. We have here lambda cubed minus 3 lambda squared minus lambda plus 3. We divide it by lambda minus 1. Okay? So that if we randomly pick, so we find this, and then what is the rate we get here? We get lambda squared. So this is lambda cubed minus lambda squared. Then we put a minus, this becomes plus. So here we get lambda cubed minus lambda cubed cancelled out. This is minus 2 lambda squared minus lambda. Then here we get minus 2 lambda. This is minus 2 lambda squared plus 2 lambda. Then we change the sign, we make this plus, this becomes minus. Okay, we subtract those, so these are gone. Then here we have minus 3 lambda plus 3. So this here we have minus 3 lambda. So this is minus 3 lambda plus 3. So they are equal, when you subtract those, 0, 0. Then we need to factor out this term, which it's easy. This is lambda minus 3 times lambda plus 1. Okay, so this is how we can factor out these. But or another trick would be the following. So actually, we can consider the first method. I mean, we were lucky enough in this case. So this is the first method. Okay, so we were lucky. Everything was easy. The second method would be this one. Once we find one root, we divide the polynomial by lambda minus 1, and then this would be the second. The third one, which is the result of subsequent of this, we can do the following. We found one lambda, which is lambda 1 is 1. So one lambda is equal to 1. But then this is lambda 1. Then we have the lambda 1 plus lambda 2 plus lambda 3 is equal to the trace. What is the trace? The trace is 4 plus 2, 6 minus 3 is equal to 3. Okay. And then we have lambda 1 times lambda 2 times lambda 3 is equal to the determinant of this matrix. What is the determinant of this matrix? Let's try to figure it out. We have 4. 4 times 2 minus 3 is minus 6 minus 8. Minus 1, which is minus 9 minus 14. Minus 9 minus 14, what is it? Minus 23, which becomes plus 23. And then we have 2 plus 2 times 3 plus 14. What is 3 plus 14? 17. This is 17. So what is the determinant? 4 times minus 8 minus 32 plus 23 plus 34. So 34, but we might have a mistake here. Probably there is. Because this ends up, the determinant, it ends up being 2 plus 23, 25. 25. But the product of our eigenvalues is not 25, it's 3. Where is the mistake? Minus 6. 2 minus 6 minus 2 minus 8 plus 23. This is minus 9. What is it? No, okay, my mistake is here. So this is minus 9 plus 14. Okay, minus 9 plus 14 is 5. Okay, so this is the mistake. So this is minus 1. Minus 1, minus 5, okay. This is minus 5, it's not plus 23. Then here we have 34 minus 32 is 2 minus 5, it's minus 3. Apparently the determinant, we can double check, it's minus 3. So this is minus 3. Now, these are three equations we can make use of. So this is the third method we can consider. So in a 3 by 3 matrix, we find one. So we have one value. Then we can use one equation for the trace, one equation for the determinant. That's 3. So lambda 1 is 1. Then from the second equation, we get lambda 2 plus lambda 3 is equal to 2. And here we have lambda 2 times lambda 3 is equal to minus 3. So from this pair of numbers, it might be imperative that one of them is 3, the other one is minus 1. So this is 3, this is minus 1. So then we end up with 3 eigenvalues, okay? And then given these eigenvalues, we can find directly the eigenvectors, and we can try at least one, okay? So let's try to determine the
Professor, we will have what kind of matrices, like 3 by 3 or larger matrices in the final?
Up to 3 by 3, you might expect it.
No, I mean in the final exam, will we have large matrices like this? Like
Yes.
3 by 3?